Have you ever wondered what makes artificial intelligence or AI? Well, in this video, I'm going to show you how to make this little autonomous delivery drone that teaches you some of the basics of AI using a finite state machine, which is a great primitive structure for structuring different behaviors called states into, functional code blocks that you can use to make stuff like this. This thing's pretty cool. It's a two-part mini series. This is the first video. Second video should be releasing with this video. Should be pretty cool. And I hope you enjoy. Like and subscribe if you do. But without further ado, let's get started. I want to make a little drone that takes packages from point A and brings them to point B. Seems very simple, right? Well, what if the package gets, like knocked off due to some like turbulent weather or something? You know, the drone can't go to point B. It'll go to point B without a package, so it'll have to go back to point A. And what if there's like a, like a wall here? It has to avoid the wall somehow. And when you go to implement this sort of behavior in code, you start off with a singular if statement. Okay. If the package is gone, then you return. And then, if the wall, like, oh, if the wall is there, you like go back. But in reality, there's a lot of like different behaviors that have to work together, and scaling it up by just leaving a bunch of isolated conditionals is a bad idea. So we're going to model this behavior to make a delivery drone in Roblox using something called a finite state machine, or FSM. And this drone, could be good for like a package delivery game, but in reality, this is just an excuse to learn about these things because they're really good for any type of AI in any game that you're trying to make. So, the first thing you want to do when making a finite state machine is to kind of model out your states. So this drone's going to have a bunch of different states. So like what it's doing at them. So for example, when the drone is going back to point A to pick up its package, because this will be like, the spawn point where all packages will be sourced from. I'm going to call this state the returning state. So I'm going to make a little box and, say it's returning. You got to admire the beautiful cursive, I know. Great handwriting. And so this returning state will go, and when it goes to point B, like the transit phase is going to be called the delivering phase. Make another box. We're going to do deliv. This time we're going for print because it's more legible. But what happens when the drone kind of like, drops the package by accident or just something happens on the way? You go from the delivery phase back to the returning phase. And once you're here, I'm going to implement a specific state for when it's like actually dropping off the package. So it's going to be a dropping state. I'm just going to call it drop. Looks like prop, but it is indeed drop. Don't mind that. And from the dropping state, obviously, you return back to the returning state because that's where you go. Now, to handle walls, we're going to make a state called like avoiding. So from delivery, you detect a wall, and this will be like the avoiding state. It's just going to be avoid. And so if you successfully avoid it, you can go straight back to the deliver state. And then obviously if something happens, you would go back to the returning state. So yeah, that's all this is. A finite state machine is basically just a bunch of different states, kind of like what it's doing at the moment and ways to move to and from them. And by clearly defining this, in a kind of diagram beforehand, you're able to implement it a lot easier in code to make it a lot simpler. So now let's hop into Roblox Studio and get to work on this drone. Okay, so here we are in Roblox. Let's start. So for our point A, which is like kind of, the drop off point for like our package. We're gonna call this the depot. We're gonna make the depot real quick. It's just gonna be a random anchored part. This is just for visual aid. Make it a little bit bigger, whatever. I'm going to use Control G on it to turn it into a model. Rename this model to the depot. This is going to be called the base. And then I'm going to make two little spheres as basically like references for some other stuff. So I'm going to make sure can collide is off and anchored is set to true. Make this just like a 1 by 1 by 1 size. Oh, I did that wrong. One. I can type right. There we go. Make it, nice, recognizable, neon red, let's say. A little bit transparent. This is all visual aid just for testing, but I like it to look somewhat decent. And we're going to move it up a little bit. This is going to be the pickup point. I'm going to rename it to pickup point, move it in a depot, duplicate it, move it up a little bit. By the way, that duplication was Control D to duplicate. And then we're going to make a blue point, and it's going to be the drop point. So the packages will drop onto the drone from here for the pickup point. And so the reason the packages are dropping, like I know in the little graphic I had, it was kind of dangling, but we don't really have time to implement that in Roblox. You obviously can, like on your own, but for this video, since it's mainly focused on the state machine itself, I'm going to make a simple system where the drone, which I'm going to make now, is just going to be a singular part. So if I can create a part, so it's going to be like a basic little part. I'm going to make it, like 0.5 by 5 by 2.5. If I can type it correctly again. There we go. So this is going to be our little drone. I'm going to make it, like a metal fur. It's going to not be anchored, have can collide on, and we're going to group it once again, calling it the drone. The part here, I'm going to name the base because it's like the base part. And this is the entire drone, to be honest, because the package will drop on top of this, and it'll deliver it to some point, and that should work out perfectly fine. So this drone needs to move. We're going to use an aligned position for that. I made a video on aligned positions if you want to check that out, but they've actually gotten a lot better since that video. So I'm going to click here to create the aligned position, and for the second attachment, just shove it wherever, and then just instantly delete it. Because aligned positions usually require two attachments to go to, like you start here and you go to the second attachment. But if you go to the aligned position, go to mode and change it to one attachment, you actually only need one attachment, and you can specify a position that it goes to. So that's great, and we'll use that in the code later. Right now, I'm going to turn on apply at center and mass to true. Make sure this make sure the transform of the C frame is centered at the part. This is relative transform, not the world C frame. And then I'm also going to set the orientation to 0, 0, 0. So it's, facing a normal area, which would be cool. Now let's also add an align orientation just to keep everything straight. Click on the same attachment that you created. And then for the second attachment, again, just shove it somewhere else, delete it, and then change the align orientation to one attachment property. Leave everything the same. One other thing you need to do is actually go back to line position. I just remembered. Change the max velocity to something like 10 or 20 or whatever. Because when this thing's moving, it'll work at whatever max velocity you set it. And by default, it's infinity. So if I tell it to go like, over there, it'll zoom there really quickly and the package on top will just fall off. We don't want that. We want our package to stay nice and safe. Don't need to be pulling like 10 Gs on this thing. So we'll leave it at like 10. Okay, there we go. So that's everything more or less done. Let's just double check everything works by playing it. The part should just move wherever. I think it's set to like 0, 0. So you see how it's moving towards its target position, which is always great. And it obviously gets stopped by this thing. Yeah, it does. Okay, so that works. Wonderful. Now it's time to start scripting. We've all been here for. Let's go to the depot. Create a new script. Here you go. Depot script's going to be pretty simple. All we need to do is drop packages onto the drone. So we're going to say local drop equals script.parent.drop point. And we're going to find a local tick speed. And I'm going to set this to something like 3 seconds. So realistically, in an actual game, you'd probably want to use a run service event for, spawning in the package. But if I'm being honest, it's more performant to do something like this where you have a wall true do and you do a task.wait tick speed, because this will only run every 3 seconds. And yes, it is an infinite loop, but it's okay because this is like our event loop. We want this to run all times. And since the actual like spawning of the package is not really time critical because of our finite state machine, it'll like stay there until it receives the package. I think this is fine. So now what I want to do, this depot has to be a little bit smart. So first we're going to detect if the drone actually exists underneath it. So we're going to say local cast equals workspace raycast a drop point dot position, and then we're just going to look down. So we're going to do vector3 dot y-axis. So that's a new vector that has x and z as 0, and then y is 1. And we're going to multiply it by -5. So this is going to be an array at the drop point looking down about 5 studs. And we're going to say if cast.instance and cast.instance is descendant of workspace.drone, then we're going to create a new package. So this is basically saying if we detect something below us and it's a descendant of the drone, we spawn the package. So one slight correction here, if the cast does not exist, this will error. So we need to add another safeguard, say if cast and cast.instance and cast.instance is descendant of workspace.drone, because if you shoot a little ray down and it doesn't hit, you got some issue. So just make sure to put that in. A little quick fix. Sorry about that. We need to create said package. So I'm just going to create a new part, give it size of 111, give it a nice little material. Let's do a nice fabric. There we go. We can make it a fancy color, like this nice blue. And making sure to leave it unanchored, and everything else is more or less fine. But what I'm going to do, and this is just like, kind of a nice feature to delineate the package, because I'm going to name this package just for our sake. But every package, like has like in real life, you have like, an address that you have to send it to. So in Roblox, we're going to make this address a vector3 and we're going to call it target. So this is the target position that this package needs to get delivered to. So in an actual game, you could dynamically set this based off the depot, like where it needs to go. But this also serves the other purpose of letting us use an attribute that will like tell us this is indeed a package. Because sometimes you can't really rely on names. This way you always know it's a package by its target. Now, if you have another part that also has a attribute that's target, kind of screwed. But for this simple example, it'll work fine. So I'm going to shove the package into server storage, go back to the script, say local package equals game get service server storage dot package. There's our package. We say local new package equals package clone. So we clone the package. We need to set the new package dot position equal to the drop point dot position. And we also need to say new package dot parent equals the workspace. There we go. So let's test this thing really quick. Move the drone about here. and it does indeed drop a package. And you can see the drone is just hauling away with this package. Right now, take the package off, nothing. The drone's not even going to the target position. We have to change that. How might we change that? Well, let's script the drone. Go into the drone. Create a new script. Here we go. We're going to say local drone. There you go. Zoom in some more. Local drone equals script dot parent. We also need to get the base for later, so we're going to say base equals drone dot base. Local, I'm going to call it mover, like for the align position, equals base dot align position, because it's kind of like what moves the drone around. We don't need a line orientation. It's just kind of there to keep it stable. It's like a gyroscope, basically. And let's get started. So to start off, we need to implement the returning state. And since Lua is so great and wonderful, we're going to use a dictionary. So we're going to say local state equal, or I guess it's called a table canonically. Local state equals a blank table. I got a video on tables, lots of stuff on that. Tables are very, very powerful because in most other languages, if you want to implement a state machine, you would make an enum and then use a case statement to switch between them. But Lua gives you the option to define functions inside of a table. So we're just going to make all of our states handled by a function that's the name of the state in this state table. So it's kind of confusing, but the way it looks like is we say function state dot return. This is a new function that is part of the state table that we'll eventually, deal with later to set the current state or whatever. So this returning state, all we need to set is the target position. So it would be mover dot position because this align position, tells the drone where to go. Set that to the pickup point. So let's get the pickup point by saying local pickup point equals workspace dot depot dot pickup point. So we need to basically just say mover dot position equals pickup point dot position. That's all we need to do now. And so we're going to do the same sort of like update loop as the depot. We're going to say local, we're going to say wall true do. We're going to do task dot wait, another tick speed. I'm going to make local tick speed equal to like 0.5. I honestly would recommend in an actual game you use run service like steps for this or something just because it runs a little faster, but I don't need the performance to be honest. So we're just going to use this little loop, runs every half second, not too often, not too stressful for the game. And in here, what we basically need to do is just run the state that we're currently in. But right now, we have no way to figure out the current state. So we're going to do that. We're going to find a variable, say local current state equals nil. Because some of these state values down the line are going to reference current state and actually set current state. So we're going to start it at nil just so these guys can reference it. But right before the wall true do, we're going to set current state equals to state dot returning. Because the default state of the drone should be going back to home base. And now in our wall true do, we're going to say current state parentheses. What this is going to do is it's going to call whatever the current state is. This is very important because Lua, although it's great because you can do things like this, it also doesn't have. Okay, I also guess I should be saying Luau because it's not Lua, but forgive me, Luau does not have the safeguards. Actually, Luau does have the safeguards, but I'm using it without types. This is a tangent. Okay, I'm using it without types, so it kind of doesn't to like verify that this is a function. So when you're doing this, you're assuming that the current state is always a function. So whenever you're writing your state machines, you always want to set state equal to a valid state. And be careful, you never want to put parentheses at the end of this returning block because that actually calls the function. You want to just set it as a value so it can be called later here. And whatever this current state changes to, it'll be called. So each tick will call the current state. Right now we only have one state, doesn't matter, but it'll obviously get crazier as time goes on. Let's run this. Does it work? Indeed, it does work. Absolutely wonderful. Let's stop it. And now what we have to do is we actually have to implement the delivering state. So actually, I'm going to go back to our package just for testing purposes. I'm going to set the target position just to something a little bit more easier to reason about. Okay, so it's kind of in the positive x direction a little bit. So we'll set this to like, positive 10 in the x, and we'll set y to like 5, I guess, and we'll leave z at 0. It's just going to be better for testing. So I just changed the target position. Not really necessary, just quality of life. In an actual game, I'd recommend setting it to like some predefined part. That doesn't unimportant here where it goes, so we're just gonna leave it there. So because we're only gonna care about picking it up and like dropping it off. We don't really care what the drop off point looks like. Could be whatever you want. So now we're gonna define a function for state.delivery. This is going to be another state where we, pick up the package and we're going to the place. While in this state, we want to be constantly checking if the package is actually on our drone, because if it's not, there's no point to be delivering. We might as well go back home. To do that, I'm going to make a function called local function get package. So this package is also going to knock out two birds with one stone. Basically, we're going to try to retrieve the package. If the package doesn't exist, we'll just return nil. And so it'll basically work as saying, okay, does the package exist? And if it exists, it'll like give it back to you. So we're going to start by saying local detected parts equals workspace get part bounds in radius. I'm going to do that from the drone get pivot, so like the center of the drone dot position and comma 1. So this basically makes like a sphere around our drone of radius 1. So the sphere is going to be radius 1 stud, and it'll detect all of the parts around there and give you a list back. So we want to check in that little sphere which of the parts, or if any, are the package. If one of the parts looks like the package, then we'll spit it back, we'll return it. If not, just won't do anything. The function will return nil. So we say for I part in detected parts do. We're going to say if part get attribute target, then return the part. So what this will do is it'll say, okay, so if we have a target, attribute that in our game right now only packages have, we give it back. Otherwise, nothing is returned. So we can use that to like, detect if packages actually exist. Let's go back down to the delivering function, and we can basically say local package equals get package. So the package may or may not exist. So if the package does exist, then we get the target position, which is equal to package get attribute target. This is a vector 3. And we can set the mover dot position, which is also a vector 3, to the target position, which is great. But if if the package doesn't exist, so else we say current state equals state dot returning. So basically, if we have the package, okay, great, go to the target that the package wants you to go to. Otherwise, we have to go back and get another package because it doesn't make sense for us to be traveling if we don't have a package. So by that same logic, we have to go up here to the returning function and also make sure that like once we get the package, so if get package, then we need to start the delivery process because this state of delivering will never really get triggered unless we do it in the returning phase. So once we actually receive the package, we go, we lose the package, we come back. So we kind of like oscillate between these two states right now. But little did I know, drone get pivot, which kind of gets like the central part of the drone, requires a primary part. So make sure you go to your drone, you go to the primary part, and you set that to the base. So now, and I'm also going to move the drone a little bit away, and I'm going to make the little pickup point part just a little bit smaller. If I can freaking skip. There we go. Okay. And make the pickup point a little bit smaller. A little bit smaller. Because if this little sphere is bigger than the flat surface of the drone, the depot won't actually be able to drop parts. So just make sure those two things are like that. The little drone will fly up, the part will get dropped, and it'll go on its way, which is great. And now if I were to drag the part off, it immediately as quick as the next tick goes, returns, picks up another part, and then flies away. Nice and green. And once it reaches its target, it doesn't really do anything. Which like not really a good look if you ask me. So we actually need to get the parts to drop. But dropping the part and avoiding walls will be for the next video. This one has run quite long. I don't want it to be too long. So make sure to check that out. Like and subscribe if you enjoyed. And I'll see you next time. Hope you have a nice day. And bye.